Tell me what you think the purpose is of this lab.
To find out like what a substance is, how much it is.
Not what it is specifically. Give me a little more. So let me add to that. You're right. You're talking about light absorption, the concentration. Right. So you're basically trying to relate absorption of light. My smartboard is having a midlife crisis here. So we're gonna go. Okay. So we're talking about how absorption is related somehow to concentration. Concentration in a liquid solution, right? In a colorful solution. Because whatever we're talking about has to be colorful, because does white, for example, like white paper, does it absorb light? Or think of like if you have white clothing on versus darker clothing on, like out in the sun. Which absorbs more energy? Darker colors actually absorb more energy, right? White colored things will actually reflect a lot, so they don't absorb as much energy. And when we're talking about light, light is a form of energy, right? Yeah. What are some other forms of energy? Light. Okay. Give me like from the electromagnetic spectrum. The electromagnetic spectrum? Hold up.
X-rays.
Okay. Ooh, thank you, Lord. Thank you. X-rays. What else? Gamma, infrared, UV, okay, radio. We have a lot of energy that's available to us, but we really only focus on, in chemistry, a lot on the middle areas of visible, some UV, because it's really close to visible, so we can actually measure things related to UV and infrared. It's very hard to measure things, and at least with the equipment in the high school lab, for gamma rays, X-rays, radio, we can really focus about right here. So IR is actually really hard for us to measure. So we're going to really focus on the UV vis is what it's called, so UV, ultraviolet, and visible, part of the spectrum as we go through some of this information. Okay, so let me start back where I was going to start here. Okay. So we know that there is a purpose, and we are actually going to do this as an inquiry lab. So College Board asked us to do a specific number of inquiry labs where I give you some information, I give you a problem, and then you guys solve it together using the information that we practiced as a whole. And so it's not me not telling you information, it's you trying to synthesize it in your head a bit more than me just giving it to you on paper and you memorizing it. So the benefits of this is that you're going to be designing your own experiments, and everybody's going to have a slightly different experiment, which is great because we can learn from each other that way, and it's going to give you a bigger, broader spectrum of information versus just the one piece of information you find from the lab. And we really have to, on inquiry labs, focus on good lab techniques so that we get data that kind of makes sense, because you're supposed to be learning from this. So make sure whenever you're doing this, you take very careful measurements, because everybody's depending on your data. No pressure. Okay, so everybody's depending on your data. So what we're trying to learn is how we can shine a light source through a solution, and how that solution will then allow some light to come out, right? But if this solution has stuff in it, okay, the stuff in it is if 100% of light goes in, what's going to come out? Not 100%, right? It depends, right? So you tell me, if I have this amount, I'm going to get, let's say, 50% of the light come out. What if I add? So something less, right? So what is the relationship you just made? What's this stuff I'm talking about? So the molecules of a particular compound, right? So I just said more concentrated means what for absorption? Oh, remember this bracket? Bracket means molarity, right? Bracket means molarity. If you don't know that, write that down. So I just go concentration like that a lot versus writing it out. So increased concentration does what to absorption? It does what? Increases the absorption. What does increasing the concentration do to the transmittance of light? Decreases it. So increasing concentration should relate to an increased absorption, and then that is inherently going to decrease the transmittance of light through. But absorption and transmittance are related in a different mathematical way. They're not just indirectly related. They're related a little bit more, and we're going to talk about that today. So we're going to look through we're going to investigate spectroscopy. Where have you seen the suffix scopy before? Or scope? Microscope. Okay, so a microscope is using light to illuminate something on a small scale. Spectroscopy is using light to do that same thing but the spectra of using light and its relationship to matter. So we're going to talk about that a little more too. But our goal is to use the specific wavelength of light and measure the transmittance of light through a solution that does absorb something. This instrument that we're using, it's called the Spec 20. So if you need to record information about materials you have access to, they're called Spec 20s or spectrophotometers, but everybody calls them just Spec 20s. And they do contain a photo detector. So when the light comes through on the other side, the detector can figure out how much light was transmitted through. So we're really depending on these instruments. And when we are using the instruments, we have access to percent transmittance for it to read percent transmittance or not percent, just absorbance. But we will always go with percent transmittance because we will learn the relationship between T and A, except the readings for percent transmittance are much more accurate than the readings for absorption. So we're going to leave it on that setting. Okay? Let me tell you a bit more here. And I have this online already. Okay, so what is the species that we are observing today? Blue dye. It's called blue 1. It's called brilliant blue dye. Okay, it's got multiple names, but it looks like this. Okay, it's huge. All dyes are huge, and they're conjugated. Conjugated means double bonds. Okay, and they're not double bonds on every single bond. You'll see it repeat. So double bond, single bond, double bond, single bond. Double bond, you can see that is conjugated throughout. So double bond, single bond, double bond, single bond, double bond, single bond, it's like this. And so electrons can actually move and they jump from single bond to double bond. It's actually something we're going to learn about a bit later too. But blue dye, does blue dye absorb blue light? No. Blue dye actually is allowing for blue to be transferred through and reflecting it. So we're actually not going to get a lot of absorption at the blue wavelength of 400 nanometers. Okay, so if you don't know enough about this, remember UV is on the violet side, so 400 is going to be the violet side of the color spectrum, and then IR, infrared, is on the red side, so about 700, 750 is going to be red light. So what I'm telling you is that here's our color at like 450, 460 nanometers. We cannot use that wavelength to absorb it because blue does not absorb its own color. So we like to use something on the opposite side of the color spectrum. So in this case, it's about here, and that's 630 nanometers. Because blue color does not reflect orange; it actually absorbs orange. So that's what the setting we have to use in our lab. Sometimes you will have to find that out by yourself, but I'm telling you for this one. So this is called a spectrum, an absorption spectrum, spectrum of different wavelengths. And so this is brilliant blue dye. You can see that it peaks its absorption at 630 nanometers, and that's why we have selected that wavelength. In the future, you might have to measure a bunch of different absorbances of a particular color and choose the highest one, and that would be your wavelength that you would set for your settings for your lab. But today I'm telling you what it is. Okay, so whenever we go through a lab like this, I'm going to tell you the wavelength. You guys are going to have a plethora of concentrations of this brilliant blue dye, and then you're going to measure its transmittance at all these different concentrations. That's going to allow us to create a relationship between concentration and transmittance. And transmittance inherently will allow us to figure out absorption. So we need to create that relationship. Relationships are basically mathematical equations. We're all pretty good with math. We all like math. The best relationship is actually a linear relationship. So we're going to be using linear regression on our calculators. You guys know how to do that? Remember that stat plot? Okay. So we need to do that because linearity creates a predictable situation. Okay. We need that because if not, we're just kind of shooting in the air and going, I don't know what's going to happen. So we need some linear relationships. And remember, whenever you're doing linreg, you do want to have your R² value closest to what? 1, and that means it's very linear. Whenever you're doing that, just a quick reminder. I don't have to call my mom to figure out how to use the calculator, so you guys know how to do that. Yeah, I did that last year. She's a math teacher. She knows all this stuff. Okay. So this is going to be instructions on how to use the Spec 20s, and I'm going to help you guys through it. The only information you really need to know is down here. Whenever we set up our Spec 20s, we have to put a blank solution in here first, and the blank has nothing in it but DI water. So the light that goes in should what? Also come out, right? That should read 100% transmittance because 100% of the light comes through. That is going to tell your Spec 20 what zero concentration looks like. So you have to do that very well first. And I have 5 Spec 20s. We do have to share one. They're a couple $100. So we haven't had money to buy another. So that's what it says, insert a blank. And then after that, you're going to insert your sample. But this is very clear in your instructions, so I'm going to go over that whenever we get back to the lab. So this part right on. Oops. Okay. This is going to be the data that we have to collect as a group, okay? So in different, I have you guys set up in 6 groups. Different people are going to take a stock solution. I'll write this down now. The stock solution that I have is 8.23 micromolar. 8.23 micromolar. So that is the stock solution. That is the maximum concentration that we have. Everybody else, all of you guys are going to be diluting that concentration down so that you're going to measure the transmittance of a new diluted solution. Do you remember how to dilute and how to use the dilution equation? Okay, so for example, if I said make a 6 micromolar solution, from that, what would you do? And I want to make a 6 molar solution that is, I'm just going to go big just so that we have different values of what's on the board right now. If I want you to make a 6 micromolar solution that's 100 milliliters, how would you set this up? Go for it, Clayton.
On one side you would have the 8.23 micromolar stock solution times V as a variable.
Okay. So this is going to be 8.23 micromolar times V, because you need to know the volume of that stock solution you need to prepare this next solution, right? Continue.
Equals 6 micromolar times 100 milliliters.
Okay. So somebody do that for me real fast. What's 600 divided by 8.23? Thank you. So V1 would be 72.9 milliliters. So in this example, what we've said is you need 72.9 milliliters of the stock solution to make this new solution. But what are you going to do to this stock solution to make it 100 milliliters? Add water. So you would need this much stock solution, and then you would add water until 100 milliliter total volume. So that's how you use the dilution equation. But the way you guys have it set up is that I'm telling you specific volumes. I'm telling you specific volumes of stock versus just DI water. Your job is to find the concentration. So you're doing it just to, you have one different variable than what that example was. So I want you guys to do that. So I have you guys set in groups. You guys are going to measure the percent transmittance and then just move the decimal over to get the decimal. And then we're going to come back and talk. So we just talked about this. We know the concentration. Whenever you're using Spec 20s, they have little tiny cuvettes. They're just small test tubes. Use the same one for all of your samples because it needs to be controlled because every cuvette is slightly different. Cuvettes also need to be wiped off clean before using because as light comes through, if there are fingerprints on it, what's going to happen? Transmittance is going to go way down. Way down. Absorption is going to go way up. It's going to be skewed. That's error for you, okay? If your fingerprints are not cleaned off the glass, you will have error. So here are my groups. So let's go Maggie's group. I don't remember who's in your group. Jacob. Okay, so Maggie's group is group 1. Nathaniel's group is group 2. Nathaniel's, my bad. Alex's group 2. Clayton's group 3. Dang it. Okay. Go to your groups. Go. I will tell you your groups in a second.
We write all our data.
Yes, please, on the next page of your notebook, go ahead and write down teacher-directed information, data, and we're going to kind of get this part done together. Go to your groups, and then you don't need goggles or closed-toe tubes for this one. This is like water and Gatorade. So, Gatorade. Okay, so let me say this again. Maggie's gonna be group 1. Kevin's y'all's group is gonna be group 2. Josh's group is group 3. Lewis group 4. You guys Diamond group 5, and then y'all's back group is group 6. These are the concentrations I want you to prepare. The only thing I really need to do for you is give you a quick tutorial on how to do that. You have special equipment. Okay. Josh, are you real fast? No goggles and signs to this. Blueberry pomegranate Gatorade. You are going to put a plastic pipette into the pipetter, and some of us maybe have used these before. My class used these. No, okay, those are special. So, this is really good, by the way. We're not going to drink it now. I don't like it. No, I want this. So all you do is scroll up. And so if you want a specific, so let's say you want 3 milliliters, come a little high, so you scroll it back down with your thumb. So what you need to do is dispense from the 3 down to, let's see, the 1, 2, 3, down to the 6. So you do that by pushing on the back side. Okay, so you can go all the way down. So if you went from 3 mark all the way down, that should actually dispense 7 milliliters. Okay, you just need to read it. What I usually do is just start out with 0 and go down to the volume I want, and then the rest of it is just we go back into the stock. So this is the stock that's 8.23 micromolar. Your guys' job is to first take cuvettes, which are in little boxes near the spec 20. I'll put these little styrofoam guys here next to you. Your job is first to make a blank. Blank is just DI water. Take your chem wipe it off, stick it into the spectrophotometer, and then you're going to make your diluted samples. This one is the stock solution actually. Wipe it off and measure the percentage bits. This will take you more than about 10 minutes. Okay, you need somebody to make solutions, someone to work the spec 20. And get your equipment. Leave the stock right here. Sorry, really fast, guys. Sorry, one more thing. These stay upright or sideways. They cannot go upside down because if you get liquid up in here, that's when I have to use your drink again, okay? Like for us. So this will get ruined if liquid gets up there. Okay? Someone needs to work on setting up the spec 20 first. There are instructions on how to set up the spec 20. Okay, there are instructions on how to set up the spec 20. Although that's specifically. I want to check your blank sample before you can really begin. So you have to set this up. Guys, please do not just open the DI water and put a pipette in. You don't even know if the pipette's clean. Put some DI water in a beaker and drink from there. Because if you contaminate the DI water, then it's
Is that 3/1? Is that like one?
yeah. So once you get everyone else going, what do you think the zero is? Once you break in there, we're going to do this. Good question. I did not say this. You will fill up to the white dot on the cuvette. Fill up to the white dot on the cuvette. Do not go above that. And when you put your cuvette into the sample compartment, there's a little dash. That dash should line up with the sample compartment dash. Because if you spill the solution in there, I don't even want to tell you what's going to happen.
Does it need to be all the way up to the white dot?
To at least like the bottom or middle. Just because you want to have a controlled place where you fill it every time. So just get a little more DI. about 10 seconds, I want to tell you one more thing. So when you get to a stopping point, look up here. Okay, and look up here real fast. Okay, so you guys have a couple of different dilutions you are creating. You need to create that solution in a little beaker because it's going to be 10 milliliters, and you'll notice the cuvettes probably don't hold 10 milliliters, right? Do not mix in the cuvette. That is for testing only. You're going to mix your dilutions in a small beaker. You're going to then pipe it up. I hope you're listening. You're going to pipe that up with your pipette, put it in the cuvette, rinse out the cuvette with that solution. Just like yesterday with the burettes, yesterday with the burettes, you had to coat the inside of the burette with your sample. If you don't coat the cuvette with your sample once or twice, then you're going to read error because it might have water in it or it might have nothing in it. So you need to coat it first, okay? So rinse the cuvette twice with your solution with just a little bit and then pour that out. And then it's going to be coated with your diluted sample. Then for real, put your diluted sample, the rest of it in there, and then test your transmittance. Does that make sense? You're basically priming the cuvette with your sample before you test it. Okay, do that. And do you guys know what your solution dilutions are? Let me pull this back up here. Make sure you know. You guys need stock solution. I've got a sample here at Maggie's station and a sample here at Chelsea's station. We'll stop here. You guys can know it about that. So I'll just make your solution. People on this side of the lab, I'm going to put this over here for you so you can feel this is stop. When you get your transmittances, I want you guys to write them up here on the board. What was y'all's concentration?
3-7.
What's the concentration? Hold on.
We haven't worked on that yet.
Do the concentration first and Fill in wherever on your particular sample, and if there was a double of that sample, we will miss that. The marker is messed up. Good.
I told you that the marker was messed up, so you just have to deal
I was
with
too busy
my.
working on my chemistry to hear.
Oh, my bad. Here, you can have a marker back. Which color you want, honey?
Blue.
You want blue? Okay.
Oh, you're boring.
Now, mark only on yours.
Oh, I was only picking from these three. I didn't know there were other options. Okay.
You just remember them?
Yeah.
Oh,
Two numbers.
and the last, I don't, you didn't do the last one.
Ooh, forget that one.
Wait, you only had to do one of them?
You just say it in the narrative.
Oh, you did that, okay.
I don't know the micromolar. Yeah, I have that. 1.646.
I don't like the way this is showing up with the, and then it's just because the sorry.
Oh, not. You got it.
Oh, yeah, I'm sorry.
Okay.
Yeah, I'm paying 0 because I'm not paying 0. All right, let's get data up here in like 5 minutes if possible, because I want you to be able to work in teams today. Go team.
Do you care if do we have to write micromolar?
No, I got you.
Go team.
Good team.
So chicken data. As long as it's going up. Yeah. I'm still videoing. I'm gonna have to crop this. Speed.
That's right.
Yeah.
Okay, so use the formula.
And then your job there was to figure out M2, which is your new diluted solution. What was the total volume of your new diluted solution? Yeah, everybody's D2. Everybody's D2. You know the M1, you know the volume of all the stuff you use. Number 2, you do know. You do know the B2. How much was, well, actually, no, see, this is your B1. See, that's the mass, and that's the volume of stock.
So that's
People have doubles. I have doubles and ones. I wanted confirmation, so if you could write it just below it.
I was looking.
How close is it?
It's pretty close. It's like
Yeah.
It's like 0.5 maybe.
That's perfect. Yeah, I just want it double. Multiple trials of the same information. So go ahead and put it up here. Read ahead if you are done so far. Read ahead. Alright, I need data on the board. My people who are 0 and 10. Like for real.
Oh, I got you. I got you.
What?
Write down data, clean up your solutions. We need to do some analysis crunching here.
Right?
Yes.
Just scratch out that. Thanks, because my eraser's not working. It's just
The red marker's green.
I know I've put some green. If you doubled somebody's, just put it right below it.
Okay, right below it. Okay.
Number 3
But
is
like, I'm trying to speak in the box.
It's 929, right?
not 292.
292. My bad.
And the percent was 31.8. And then 0.318.
Yep.
And then this one was
3 was 4.938.
9.
And then 20.8.
And then I'm gonna get a different color. Go for it. Start it.
20.8%. And then 0.208.
All right, I need a couple more people's data. And so, which one's yours? I'm gonna say where we're write it.
And then I need to fill in this one, and then this one, and then we're working on these
So
right now.
this column.
Yeah.
Then write it. Comma. Okay. Yeah, so I have double data, so I'll tell you specifically. All right, can I get data in 1 minute? Because we need to do analysis before you guys leave today. I want you to start your other procedures.
So we already have both sets of data for each one?
What are you saying?
Is there 2 for every one?
No, not every single one. So you'll see this one says comma. This is 31.8 and then just 30.00. So it's concurring with each other. It's close. You can write down those data. And you guys can clean up your concentrations, throw them down the drain, turn off the safe 20s. Yeah, you turn this out on the left.
Do you want me to show you the different colors?
Yeah, I have it right over. Which one is yours?
The 3 and the 1.
This one?
Yeah,
Okay, So put comma. How did I get your head out of the way? Exactly. Oh, well, that's the same. Sorry, I forgot about that. This is your other data. Can you write it like right below it right here? Beautiful. And then over there. What's your other one?
Yeah.
Same story. That's the same. Just right below right here. Or in the corner. Clean up,
This has
please,
stuff in
and
too, by the
thank
way.
you. That's good. I got you.
We got the same numbers.
Yeah, we all should, because that's a given concentration.
Okay.
So we're good there. Okay, clean up, and I want you up here in 1 minute. Okay, clean up. I want you up here in 1 minute. We need to do the data. Turn the spec 20s off. I turn the left knob all of the way. The left knob down. I'm going to, excuse me? Yes, left knob all the way to the left.
Wait.
I'm going to go back, hold on. Before, I'll, wait, because I'll go back here. Pull up stat plot, or linear regression, or whatever in transmitters.
What you want us to do is like to.
Write them all down. Write down the data.
Should I get a different?
Yes. You can borrow my yellow one right now, but you need to get one, because you're going to want this for.
Do it.
No, that's it. Just go back. We're gonna talk about that one. Okay, guys. So we've collected data at this point. We now need to figure out the mathematical relationship between transmittance and concentration. So mathematically, there are a couple relationships you can think of. Well, I know that we talked about, trying to get linearity already. But what are some mathematical functions that come to mind? I'm trying to think what's another way to say that. What are some functions you learned in Algebra 2? Interesting things. Or even think pH.
It doesn't turn on.
Logs. What else? Must be the batteries. What else? Logs and natural logs. Yeah. There's all kinds of different functions out there, but we need to figure out which one creates a linear relationship. So the way we do that is we need to plot in our stat plots different variables or different functions related to these variables here. So what I need us all to do is a different function. We're going to figure out the linearity here. And I will go back here, but I need to tell you the functions first before we move on. Okay? Oopsies. Oh, wrong way. Okay, so, these are the couple of different types of relationships that we can use. We can use mathematical functions of indirect proportionality. So like we can graph 1 over transmittance versus the dye concentration. We can do an exponential kind of relationship versus dye concentration. We can do log versus dye concentration and negative log versus dye concentration. We need to do all 4 of them. So let's break into groups. Let's get this in our stat plot. You can see that I have them noted as that versus what. So the first one is going to be X. The second one's going to be Y, or C1 and C2, whatever your list are called, L1, L2. So can you guys do this whole group here, do 1 over transmittance versus dye, and figure out the ln reg. You guys do the second one. So 1 to the times 10 to the T, and then you guys in this group here do log of T versus dye, and you guys do negative log of T versus dye. Okay? So you're putting these values of T, so not T, the decimal form of transmittance, and then the concentration of dye in your 2 list. But some of us need to take 1 over T when we're putting it in our calculator. Some of us need to do 10 to the T in our calculator. Some of us need to do log of T in our calculator, and so forth. So can I go back? You know what you're doing. Can I go back to the data if you need it still? This way. Okay. So whoever's doing, whichever variation of transmittance, you need to take the decimal forms of them and adjust them. You guys need to help each other on the calculators because my calculator is slightly different than yours. Yes. You guys are doing negative lots.
You want to do
Yeah.
logs?
They are doing the positive log. You're doing the negative log. After you put your data in, you're going to run a lin-reg and figure out your R-squared value is.
If we have two different like T%, do we just put both?
You just double, yeah, because it'll still do like linear regression
You do a log of the term.
of the decimal form. You guys are not doing log. You guys are doing 10 to the T, right?
Yeah.
10 to the decimal.
Oh, no.
So this group is doing 1 over T. You guys are doing 10 to the T. You guys are doing log of T versus concentration.
Wait, what? Why are they red?
Red. These are extra data points. So like this is the concentration, this is another data point. So you have 2 data points for each of these, for anything that's doubled. You should be able to get your R-squared without doubling or putting in all the data, but the more the merrier. So maybe somebody else in your group did. And when you're graphing these, concentration. Which is the independent variable? Concentration or percent transmittance? Concentration is the independent variable, so that's the X actually. And then the transmittance is dependent upon that, so that's going to be graphically the Y. So when you do your assignments for lin-reg, assign the concentrations as the X axis and assign the whatever your variation T is as the Y. Yeah, what'd you guys get for? Kevin, tell me what you got. Are you fixing it? You guys had 1 over 2. Tell me your Y equals MX plus B, and tell me your R-squared value. How do you guys get there? .98044. What's your Y equals MX plus B? Or just hold it and I'll get it after we all get everybody's R-squared.
Okay. No.
Zach, you guys have your lin-reg? Do you from your 2 lists linear regression and assign the 2 lists of
How do you do that?
You do have to turn the diagnostic on, yes.
Scroll down to on diagnostics.
How do you turn the diagnostic on?
Second catalog, and scroll down till you find it.
Second, 0. And then you can hit alpha, and then whichever one has the letter D, it'll take you to the D's. And then scroll down to diagnostic on and hit enter.
What were we supposed to do with the one transition to the T?
That goes in your Y column, your L2, yes.
Yep, just click diagnostic on and hit enter twice.
In your Y values or variation.
So I don't plug those numbers in.
No, you put 10 to that. You guys have yours? Okay. Alright.
Oh, I got it. That's why I like this.
Jack, what'd you get? R squared, Jack.
R squared, 0.5731.
Okay.
You know all the numbers?
I just want that separate. Keep it up though, okay? Anybody else? Y squared is what's your R squared value? What's your R squared value? Can you tell the red one?
I used all the.
What? What's that?
Did you put in all the data?
Josh?
One over the decimal. Okay. How do you get A to be 114?
Can you finish yours with the green?
Derek, how did you get these numbers over here?
Huh? You still have I will.
Into the,
We need to take class here one person will be concerned about that. I'm waiting on the negative L, negative log.
Wait, Miss and Low.
Yeah.
Me and Kevin have completely different ones for R squared.
Tell me what you got.
I got 0.1688.
This is more what I thought. More 1, 6.
I got it intensely like the
But I'm waiting for Clayton to finish. I want to see
Don't you know what to do?
Yeah.
You got
Hold on.
one of them.
I don't know what.
You know the one. I haven't gotten it.
I think you're
So
Okay.
much to the.
Kevin, double check y'all's because I don't think that's right. I don't think that's right. Okay. What'd you get?
we got like completely different.
For
I don't
this?
even know what to do with it.
Yes.
Different numbers on
How
it.
different?
I got,
Did you put L1? I mean, did you put X as the concentrations?
yes. I got like R squared is 0.466.
That's not bad. I got you. That's good. That's close. Yeah. Okay. Can we concur that this is good enough data for now to make an assumption? Okay, so what we should realize is 1 over t is crap, right? Not linear whatsoever. Kevin's making stuff up, okay? That's not right, okay. The t, 10 to the t, not very linear, right? Because r squared value closest to 1 is going to be the most linear. Log of t is pretty good. You know, it's getting there, but negative log of t is the most linear relationship. So what we assume then is that the transmittance versus concentration is related to each other by negative log of t. So the formula that we need to use, what's your y equals mx plus b now, guys? That's this group, y equals mx plus b. Write this down. This is the relationship. Y is equal to slope. The pressure, guys.
Alright, yeah, Y be 0.066.
Are you telling me slope right now, or telling me A?
Okay, slope is 0.114.
0.114 x plus what? What's y-intercept?
0.066.
0.066.
No, just 0.006. 0.006.
Let me erase this. Okay, write down that value. That equation. Yeah.
I got like 0.952.
952. Even if that is right, the other one is still more linear, right? Right?
0.066.
I got you. I'm moving it. Dang it, my marker system. Isn't the other one still more linear?
Yeah.
Yeah, so I'm gonna stick with that for now, okay? Because I know that's right. Okay, so 0. I was right the first time. Thank you. Okay. 0.66. All right, so there's our linear. That is our relationship between the concentration and the transmittance. So what does the graph look like? What are the axes? What do we just graph?
concentration.
So the micromolar is the concentration of the blue dye, Okay, and what was over here?
Percent T.
Okay, as a decimal. So I'm just going to put like decimal T just so you guys realize that's the percent as a decimal. Okay, and then this graph is a positive or negative relationship. Positive. Okay, so whatever, oh, and let's pretend this y-intercept is 0.066 there, okay? Our goal is actually to have a y-intercept of 0, and that's really dang close because anything that intercepts at 0 makes the relationship very easy to predict. So it's all about predicting. So that's just a quick intro on everything you needed. So it took a lot of time to kind of get the data, but I appreciate y'all helping me out there. Can I go forward? Okay.
Do we need to
Or
do
wait.
like a accurate graph or
You can do a sketch. That is fine. That sketch is horrible, but do something better for yourself there, okay? But as long as you write down the y equals mx plus b, you can always reproduce this graph on your calculator. So what your goal is for now, we have less time than I thought. We have about 15 minutes left. Your new goal is for us to do a similar experiment, but one designed by you guys that will solve a similar problem. I'm going to give you an unknown concentration of a particular, of the dye, the same dye, okay? I'm going to give that to you, and your job is to find its concentration. What do we do in the lab today? I gave you what? And you found, I gave you concentration, and you found transmittance. So what am I asking you to do? The opposite. Okay? So your job is to read, this is your reading for tonight, it's literally a paragraph. And your job is to create a procedure to do that, to solve that problem. So your problem is this. This is on your paper, okay? This is on that paper. Your mini-com squirt strings contain blue dye. Students will use the relationship between transmittance, observance, and concentration, as well as their calibration line from pre-lab. What is the calibration line? Calibration line? Calibration line. Label this as calibration line. You need to know that a linear regression line is a calibration line because it allows you to extrapolate. What does extrapolate mean? Okay, you can continue, extrapolate, and if something were lower, you could extrapolate that way or interpolate. So maybe, let's say I gave you a transmittance. If I gave you a transmittance, could you find the concentration using this graph? Right, what do you do? Okay, you could plug it in where in the formula? As y. Or if you wanted to trace on your graph, you could go find the transmittance and drop it down to the concentration. This is a tool. Use your tools, right? Okay, so this is your job. Your job is to make a procedure using all the information, data collection techniques that you found out today, and determine the molarity of the blue dye in a concentration that I make up for you guys for tomorrow. So I'm probably going to give everybody a different concentration. All right? So what I need you to do, though, is make that procedure and share it with me on Google Drive. So if you don't have a Google Drive account or Google Docs account, you need to make one. Your school account ones that they had last year, they said are gone. So whenever you make an account, make sure that you immediately share your documents with me at my email, jessica.inlow@apps.cabarrus.k12.nc.us, okay? So, and there's instructions right here on how to share, if you're unsure on how to share. I just want to show you exactly what you need to do. So, basic format for any inquiry procedure lab is to color code. So make a list at the top, Maggie's in purple, whoever else is in your group in whoever's different colors, okay? Title, lab, and date, you know that. Materials list. List out everything you need because I'm going to pull all the materials for you before tomorrow. Okay, and I need you to submit me your procedure by 10 p.m. tonight so I can review it, make comments, make sure that it's legit. And I'm going to leave wiggle room for you so you can try things, but if I think something's going to be like a disaster, I'm going to say, hey, like, we should change this. Okay, so you're going to have some time to kind of play and figure out what to do with your life here, okay? So give me a step-by-step procedure, be specific so that I could repeat it if I wanted to, or that another student could repeat it, and any special cleanup. Does it make sense? Okay, if you would like to collaborate now, I did get the laptops for us to do Google Docs today. You guys have about 15 minutes left in class total. You can collaborate and plan, but everybody needs to be on that Google Doc, okay? Go.
I don't understand this.
What do you not understand? Tell me. No, tell me specifically.
I can just get a laptop.
Let's see here. I don't have a graphing calculator. I've never done that, so I don't understand it.
So basically what we just did was we literally calculated from the data from that percent.
Yeah.
We took the decimal of it, and then we did a mathematical calculation. We did 1 over that particular, that
1 divided by whatever.
And then whatever its concentration is, once you get that on a graph, so 1/T and then micromolar, you plot it, okay, maybe like, 0.8, blah, blah, blah. Or 8.2 micromolar.
We do that with the rock that we already
I'm explaining to you just the first question. So once you got your data point and then this data point, you plotted it, right? And your calculator's doing that for you because it's taking hours as you find out. So what you're plugging in your calculator is you're plugging in the value and the calculator's calculating that and it's plotting it on a graph. It's doing that 20 times over 20 data points. And so when it plots it, it might plot it like this. Okay, that is a mess. That's a scatter plot. That's not linear. So when we did our linear regression, we tested the linearity of this data. Well, that linearity of the data is crap. That R-squared value is like low, right? So we did that for each different relationship with T. So I had each person do a different one because we needed to test them all to figure out which mathematical relationship created a line.
Really?
Yeah, he said.
That was most linear. That's
Which one
it.
was it?
Negative 1 T. That's what I looked at everybody's R-squared values, and this one was the closest to 1.
Yeah, no, he told us.
These other ones, this one was closer to 1, but not as close as this one. Okay, so this now gives us that this is the relationship between transmittance and molarity. Okay, and that's what the reading is right here. Here you can read more about the reading. That's what I want you guys to read as you do your homework. So now what we did today in the lab is I gave you a molar concentration. You found the transmittance.
So are we supposed to find the transmittance and molarity, or the transmittance already?
You have tools that you know how to use now. Your goal is to, in the end, find the concentration of a dye of a sport team that I give you. So collaborate with your team. You have tools and you have data on how to approach this, but I'm giving you a different problem to solve.
That paragraph that we're supposed to read, is that on your website?
Yes. And it's linked under homework, and it is on, I thought it was on your reading. Is it not on your lab? It's called Enduring Explanation to Strengthen Student Understanding. I can't remember if it's on the lab or not.
I don't think so.
No? Okay.
Some of the other stuff.
So, question, Clayton. You take it here again. Do you have an email question?
Nathaniel, do you have an email?
I only have it when I'm in school.
So, no.
No, you need to make.
Okay, so make one.
JWI.
Using whatever lab technique you want. Trained you. Okay.
Just to make it Google Doc.
You guys need more than that? Because data, you want more trials? Okay. You want more trials? Or this is a very simple experiment.
You go to gmail.com and say, make multiple choice. Yeah.
So we get this, so in this now, we have this, we don't have the concentration. I'm asking. Do we have it? Or do you get them?
I'm not getting it, but you have tools.
You get it.
Well, that's mathematical tool. You plug T in, you don't know concentration, right?
We don't know nothing.
Right now, the only thing we do is right, just like that one. What tool do you have? What is that?
Okay, well, did you shut it off?
Yeah.
There's probably no point in getting another one.
Why?
You can do it later tonight, and by the time you get into another one, you're not gonna, I'm just saying, I grade that one up, but don't go.
And we can do this after around because I would be able to.
What do you mean?
I don't know.
You have to read that. Yes.
Yeah, we don't understand. We have to read it.
You need to read it, but then in the Google Doc is where we'll do an inquiry procedure that all three of us get.
What do you do when it says download Google Docs?
You shouldn't have to do that.
Yeah, I know.
Mine is taking forever, so.
Yeah, we're not gonna get into that.
Okay, I'll make one.
Okay, are you making one now?
Yes. Let's see what you
Maggie has done wrote 3 at gmail.com.
What is ABS? ABS is
Absorption.
You're not checking any of my homework books, are you?
How much more?
Okay, the labs, you can do all your lab work right now on Google Docs, and then after I approve it, you can print out your Google Doc and keep it in your lab notebook, okay? Do you need your lab notebook for the teacher-directed information to do your homework tonight? Yes? If you're like, I don't need a lab notebook, you can go ahead and give me feedback on the hydrocarbon lab. You can leave your lab notebook with me during my planning. I should have it done by the end of the day or tomorrow morning. I'll give it back to you, so you can add your student data to it. If you need your lab notebook to do your student-directed lab, then keep it. Yes. Yeah, it needs to be done. No, not the teacher. I'm sorry, the hydrocarbon lab. No, the teacher-directed lab and the student-directed lab are collected. They'll be collected together. So your hydrocarbon lab, you should have a conclusion.
Yeah, I got it. So if we need it.
So we can turn in your notebook tomorrow. You can turn in your notebook tomorrow if you need your notebook for some reason, but if you would like for me to give you feedback, when I say feedback, that is not a grade yet. Like if I'm not taking up everybody's notebooks, I will just strictly give you feedback and not grade. When I take up everybody's notebooks, I will grade.
What will be able to get?
I will give it back to you, yeah. Hopefully today. Yes, jessica.nlow@apps.barris.nc.k12.us. Hold on. It's on my, I thought I put it on that doc. Oh, I'm still videoing. Oh, my lordy.
It's not just at Barris, right? It's at apps.